Hello students, I am Mansi Agarwal, ABES Engineering College Ghaziabad. Today I will be discussing the topic linear search. So as we know that linear search is a searching algorithm that works by sequentially checking each element of the list one by one until the target value is found or the list or the array ends. So the basic idea of linear search is to sequentially traverse the array, to sequentially go on each element of the array and to check whether that element is equivalent to the target value which we want to search. That is why it is also called as sequential search. So this is a very brute force approach or the naive approach in which we will simply go on each element and we will check whether that element is the target element or not. So let us take an example wherein we have 8 elements 3, 5, 2, 9, 7, 10, 15, and 6. And we have to search whether an element 10 is there in the list or not. So let me just quickly make the array. As we know that this array is having 8 elements 3, 5, 2, 9, 7, 10, 15, and 6. Let us suppose the index of the array begins with 1. So the indexing will go from 1 till 8. So in order to perform the linear search, we have to simply take a counter. Suppose I take a counter I, and with the help of a loop, we can go on each index of this array. Then, with the help of the index variable, we can check whether the array element is equivalent to the target or not. Right? So let us suppose we have a variable with the name target, which is having the value that we need to search. We can take an I variable which begins with the first index, that is 1, and it will go till the last index, that can be n in general. And what we have to do is we have to simply check whether the element of the array, that is AI, is equivalent to this target or not, the target value or not. Definitely, if these two values are equal, then we have to return the position, that is, we have to return the index, so we can return the value of I. But suppose we are searching any value which is not there in the array, then in that case, this whole loop will be executed till n, and for the value of n minus 1, we will come out of this loop. In that case, we can return a value which can show that the search was unsuccessful. So in this case, we can return minus 1. So if we come out of this loop and we have not found the target value anywhere in the array, we can simply return a value minus 1 to show that the search was unsuccessful. So if we see that how this algorithm works for the example that we have taken, in the first iteration, the value of I will be 1 and the value of A1, the value of A1 is 3, which is not equals to the target value. So the condition will be false and we will not go inside this conditional state. Rather, we will go on to the next iteration of the for loop and the value of I will become 2. So the value of A2 here is 5. Again, this is not equals to target. We will not go inside the if condition and we will go on to the next iteration. In the similar fashion, we will keep on checking for A3, which is 2, and then we will go for A4, which is 9, then for A5, which is 7, and then when the value of I will become 6, then the value of A6 will be 10. And in this iteration, the condition of AI is equals to target will be true, and the control will go inside the if conditional statement. Value of I will be returned back. So in this case, we will get the value 6. So we can just see the algorithm. The name of the algorithm can be linear search. The number of parameters are A, that is the array in which we have to search the target. N is the total number of elements in the array. And target is the value, is the key value that we are searching for. Then, in order to begin the algorithm, we have to start a for loop. Starting with the first index, it will take a value 1 and it will go till the last index, that is n. For all these values of I, we have to check whether AI is equals to target or not. If at any point of time, the value of AI will be equal to target, then this index I will be returned. That means we have found the target value at the index I. And in case if we do not get any value which is equivalent to the target value in the array, then for the value of I equals to n minus 1, n plus 1, we will come out of this for loop, and in that case, we will return a value minus 1. So let us now try to implement this code. In order to implement, let us take a new file. Let us include the standard input-output header file, as we have to use the printf and scanf functions. Inbuilt function can be named as linear search, and this function will return the position of the target. So the returning data type of this function is int. Coming on to the parameters, first parameter is the array in which we have to search. The second parameter is the number of elements in the array. And the last parameter is the target value that we have to search. Inside this function, we can start a for loop with I, and the beginning value of I should be 0 as we are working on C and the index of the array starts with 0. And it will go till the last index, that is n minus 1. For every iteration, we have to increment the value of I by 1. Inside this loop, we have to check whether the value of AI is equal to the target or not. So we have written a condition that if AI is equal to target, then in this case, we have to return the position. So we can also return here I plus 1 as the index is starting with 0. So in order to return the position, we have to return I plus 1. If we have not found the target value in the array, then this loop will be terminated for I is equals to n. And in that case, we can return a value to show that the search was unsuccessful. So I have returned minus 1. Coming on to the main function, we can take an array. Suppose we have taken an array of size 20. We have taken n, input the number of elements in the array, and we have taken another variable with the name val to input the target value that we have to search. So let us first take the input from the user about the number of elements that user wants to enter in the array. This value can be taken inside the variable n, and then we can take the array elements as input. For taking input, we have to again use a loop from 0 to n minus 1. And we can write down the scanf function, wherein we are supposed to input the elements, that is AI. We can also give a message to the user stating that which element. Now, after taking the array elements as input, we have to take the target value that we have to search. So let us give a message to the user that enter the value to be searched. And we can take this input in the variable val, as we have already declared this variable for the purpose. Now, the next task is to call the linear search function with array A, number of elements n, and the target value val. But this linear search function will return us the position of the target value. So here we have to also take a variable in order to store the index that is returned by the linear search function. And in the main function itself, we can simply check whether the position that we are getting is -1 or not. If it is -1, then as we know that it is unsuccessful search, we have not found the target value in the array. So we can write that this was an unsuccessful search. And in all the other cases, we have got a valid position, valid index. So in this case, we can tell the user that the value which the user was looking for, that is the value %d, is found at %d position, where the first %d corresponds to val and the second %d corresponds to position variables. Now, let us try to run this code. Number of elements in the array. Suppose there are 5 elements. Enter the element number 1. Suppose this is 20. Element number 2, 30. Element number 3, 10. Element number 4, 40. Element number 5 is 50. And the element to be searched is suppose 40. So the value 40 is found at 4 position, right? And suppose let us run this code for an unsuccessful search as well. So suppose the number of the number of elements are 5. And again, the elements are 10, 20, 30, 40, and 50. And suppose the value to be searched is 35. So this is giving us unsuccessful search. Now, let us see the time and space complexity for this algorithm of linear search. Suppose if we are searching an element which is present at the very first block of the array, at the very first position in the array. So in that case, what will happen? The searching process will iterate only for one time. So this is where we get the best case of this algorithm. The best case complexity for this algorithm is when the value is found at the very first block. And in this case, the complexity becomes constant, that is O1. But what if we are searching for an element which is not present in the array? In that case, we have to iterate the entire array. We have to iterate the entire array. And this for loop will terminate only after n plus 1 iterations, right? So this is the worst case when the for loop will be iterated for n plus 1 times. And in this case, the complexity will become O n plus 1, which is written as O n, which is written as O n. So in this case, the worst case and the average case complexity of linear search will become O n. What about the space complexity? So if we talk about the space complexity, as we know that for the linear search, we have only taken a target variable. We have only taken a target variable in order to store the value that we have to find. And we have only taken a variable I to iterate in the entire loop. So we can see that we have not taken any data structure which is dependent upon the number of elements n. So in this case, the space complexity will become O1. So here we can see that the average and the worst case complexities becomes On, and the best case complexity is O1. While the space complexity of this algorithm is O1. So the references that we have taken for this video includes data structures using C by Tenenbaum and Langsam. And we have taken fundamentals of data structures by Horowitz and Sahani. Then we have taken data structures, Shom series, and data structures using C by Thareja. Thank you.